Today's lesson is about word problems. There will be no new formulas today. We will just be using a variety of formulas that we've learned this chapter. So before we can begin, I do want to give you one definition. So a bearing. A bearing is the direction in which you have to move in order to reach an object. A bearing is a clockwise angle from north. So an example that I'm going to draw right now, the house is at a bearing of 335 degrees. So what this means is that starting at north, I need to move clockwise 335 degrees. So here would be 90. When we get down to south, I'm at 180. When I get up to west, I'm at 270. So what I need to do is I need to move an extra 65 degrees to get to where my house is located. So what I know is that this red, so from here all the way clockwise to the house, is 335 degrees. Now that would be a really ugly number to work with when we're dealing with a triangle, because what I see right here would be a triangle that I'm using here. So what I can do is I can say 360 subtract 335 to get the 25 degrees that I'm probably going to be using inside of this triangle. In the first example that we're going to be doing, we have a ladder leaning against a wall, making an angle of 31 degrees with the wall. So it goes on to continue to say that the ladder just touches a box that is flush against the wall and the ground. Sorry, this should say and. The box has a height of 64 centimeters and a width of 27 centimeters. How long is the ladder? So before I begin, I'm just going to draw my wall and my ground. Now, it said that there's a box and that the ladder just touches that box. Let's throw in the information that I know. So I know that the ladder is making an angle of 31 degrees with the wall. I also know that the box has a height of 64 centimeters and a width of 27 centimeters. My end goal is to know how long the ladder is, so how long this blue line is. Now, I don't think that I'm going to be able to solve this large triangle by itself, so what I am going to have to do is I'm going to have to solve this little triangle and solve this bigger triangle and add up the x and the y that I have here to get the height of my ladder. Before I do this, since this top angle is 31 degrees, I also know that this bottom angle will be 31 degrees. Since I'm dealing with right triangles, I know that I'm going to be using my SOHCAHTOA. And it doesn't matter, but I'm going to solve for x first. If you choose to solve for y first, that's okay too. So what I'm going to do basically in yellow here is I'm just going to redraw this top triangle and throw in any information that I know. So I know it's a right triangle. I know that the angle up here is 31 degrees. I also know that the bottom is 27 centimeters long because that's how wide my box is. Because of this, I can start labeling my triangle. My goal is to find my hypotenuse, or my x. Since this is the angle that I'm given up in the top, I know that I also have my opposite. What this means is that I can use the formula sine of theta equals opposite over hypotenuse, or my SO. Next, I can fill in my information. Sine of my angle, which was 31 degrees, is equal to opposite, which was 27, over my hypotenuse, which was x. Since this is an x on bottom kind of question, I will be switching the x with the sine 31. So x is equal to 27 divided by sine of 31, and if I do that on my calculator, I will get 52.42. The next thing that I'm going to do is solve for this bottom triangle, or my y. So again, I'll redraw it here. I know it's a right triangle. I know the angle at the top is 31, and this time I know that the height of this triangle is 64 centimeters. So because of this, I can start labeling. I know that I'm solving for my hypotenuse. This time, the 64 is my adjacent, which means that I will be using the formula cos of theta equals adjacent over hypotenuse. Cos of 31 equals 64 over y. Again, my variable's on the bottom, so I'll be switching. Y is equal to 64 over cos 31. Y is equal to 74.66. Moving this back down so you can see the entire diagram, what I now know is that my x was 52.42 and my y was 74.66. Therefore, I have 52.42 plus 74.66, and I know that my ladder is 127.08 centimeters. So in this example, it says, Miss G has a triangular backyard with side lengths 27 meters, 21 meters, and 18 meters. So before I even continue, I'm just going to draw this out. 27 meters, 21 meter, and 18 meters. She bought a bag of fertilizer that covers 200 meters squared. Will she have enough? So before I begin, I do want to just draw in some more information. So basically, this is an area. So my end goal is going to be to find the area of this triangle. So we know that the formula for area of a triangle is equal to base times height divided by 2. When I look at this diagram right now, I know my base, but unfortunately, I don't know my height, the straight up and down height that I need. So this is what I have to solve before I can even attempt to find my area. Since I know 3 sides and I don't know any angles, I need to find an angle before I can do anything else. This is not a right triangle overall, so I do need to be using either the sine law and the cosine law. The cosine law is going to be what I'm using because in order to use the sine law, I need to have a pair, which I do not have. So I'm going to go ahead and I'm going to write the formula for angle for a cosine law because that's what I'm going to be trying to find. And I could either be finding this angle in the bottom right or this angle in the bottom left to help me find this height. I'm just going to be choosing this angle in the bottom right just for fun. So now I have my formula. Angle C is equal to cos inverse of a squared plus b squared minus c squared divided by 2ab. Since I'm attempting to find this angle, I know that the only thing that matters is that this 21 is my C. So angle C is equal to cos inverse of, I'm just going to call this 27 my A. So 27 squared plus 18 squared minus 21 squared divided by 2 times 27 times 18. Now I know that angle C is equal to cos inverse of, on my calculator I'll do the top, 27 squared plus 18 squared minus 21 squared, and I will get 612, divided by 2 times 27 times 18, which is going to give me 972. Now if I do the cos inverse of 612 divided by 972, I'm going to get 51 degrees. So I went ahead and just redrawn the triangle on a separate page so we have more space to write. I just drew the 3 lengths and now I filled in this angle of 51 degrees. Now that I have this, I can see that when I'm trying to find my height, I have a right triangle here. In this right triangle, I cannot use the 21 since that's the length of this whole entire thing on the bottom. So what I will be using is the hypotenuse is 18, My goal is to find the side opposite the angle 51, so that's going to be my O. So sine of theta is equal to O over H. Sine of 51 is equal to x over 18. Since my x is on top, I get to move that 18 over, and I get to say 18 times sine of 51 is equal to x, and x is equal to 13.99. Now that I know my height and I know my base, I can go ahead and I can figure out my area. So area is equal to base times height divided by 2. So a 27 times 13.99 divided by 2, which equals 188.73 meters squared. Since my fertilizer covered 200 meters squared, therefore, yes, she has enough.